Hi, boys and girls. Today is Thursday for all of our reading ELA section. Um, you should have already completed all of your work for Monday, Tuesday, Wednesday today. Like I said, it's Thursday. And remember, on Monday and Tuesday, we did some technical, Monday and Tuesday, we did scientific text. And then yesterday, for Wednesday's lesson, we did uh, technical text. And our technical text yesterday was battery powered. Okay, so today you're going to read another technical text, and as a read, we're going to be looking for relationships among the steps in the process of using water to create electrical power. Okay, so let's look closely at this and let's read. First, I'm going to show you, I had to pull it up, sorry. Remember to do, here's your bell work, and then today's reading, I'm going to click on that. Get that up. Give it a second. Here it comes. You're still required to read it, but I'm going to read it out loud with you. So let's look at this. We have some words to know. We're going to look at, as we read, we're going to look beyond the words to figure out what they mean. Demand, facilities, efficient. Now we know demand, like I demand to have food.
Miss Alvarez, we need you in the front desk, Miss Alvarez.
Yes.
Thank you.
I'm still at the school. Facilities, well, we're going to read to see what that word is. And efficient. So facilities could actually mean several things. It can mean we all have facilities in our bodies that work like systems, or facilities could be the school here where I'm at. There's a large facility here that houses teachers and students, okay? And efficient means doing something really good. So when we look at the title, hydroelectric is a very, very long word. But I see hydro, we know that hydro means water, and electric we've been studying all about, and we know power. By the United States Geological Survey. So also when I'm looking at this, I see pictures. I see another text feature of like a caption there. As I'm rolling through it, I also see a diagram and more captions explain, and it's illustrated there. This is not a picture there, that's an illustration. And then here's a heading there. Okay, and then our other stuff that we're going to get to. So let's go ahead and get to this read. So just how do we get electricity from water? Actually, hydro and coal-fired power plants produce electricity in a similar way. In both cases, a power source is used to turn a propeller-like piece called a turbine. The turbine then turns a metal shaft in an electric generator. The generator is a motor that produces electricity. A coal-fired power plant uses steam to turn up the turbine blades. A hydroelectric plant uses falling water to turn the turbine. The results are the same. Now, when I'm looking at this picture here, it says, this photograph shows a Hoover Dam built on the Colorado River in the southwest United States. The dam generates electricity for parts of Nevada, Arizona, and California. So it doesn't look very big, but it is huge. These are cars. Do you see the cars, how little they are? And this is a big ravine. So what they did is they had to dam it up, just like how the beavers did. They put, instead of using sticks and logs, of course, they use concrete. So they had tons and tons, literally, of concrete that they stacked and reinforced. It's so that down here is all of the turbines that create the electricity, and way up here is the river. Okay, so let's keep going. A typical hydroelectric dam is built on a large river with a large drop in elevation. The dam stores lots of water behind it in this reservoir, and that is that big lake area. Near the bottom of the dam wall, there's a water intake called a penstock. Gravity causes the water to fall through the penstock inside the dam. At the end of the penstock, there is a turbine propeller, which is turned by the moving water. The shaft from the turbine goes up into the generator, which produces power. The power lines connect to the generator, carrying electricity to your home and mine. The water continues past the propeller through the tail race. The water then flows into the river past the dam. By the way, it is not a good idea to be playing in the water right before when the dam is released. Okay, so I keep going here. There's this picture. It has numbers on it. 1, that's what we just read. The water enters through the penstock. So it's kind of like a trap door, it looks like. And the penstock looks like a little tiny, like a narrow area that the water can go through. The water turns, whoops, sorry. The water turns a turbine propeller so the thing goes round and round. And then the generator produces power, which is carried by the lines. Now, we know what those power lines are, those big giant things that we see outside. Now, here in Bradenton, you probably don't see it. You have to drive down like State Road 64, State Road 70 to see the giant power lines. There's giant ones, like these big giant ones, okay? Next, it says pump storage, using water for peak electricity demand. Demand for electricity is not flat and constant. Demand goes up and down during the day. Overnight, there's less need for electricity in homes, businesses, and other facilities. There's that word facilities. Remember I said that our school here at Daughtry Elementary is considered a facility. It's a home. I mean, it's not a home. A home is where I live and where you live. But right now, because I'm here at Daughtry, it is a facility. For example, at 5 p.m. on a hot August weekend day, there may be a huge demand for electricity to run millions of air conditioning. But 12 hours later, 5 a.m., not so much. Hydroelectric plants are more efficient at providing peak power demands during short periods than fossil fuel and nuclear power plants. One way of doing this is by using pumped storage, which uses the same water more than once. Pumped storage is a method of keeping water in a reserve for peak periods of power demand. Pump moves water that has already flowed through the turbines back to a storage pool above the power plant. This happens when a customer demand for energy is low, so that during the middle of the night, the water is then allowed to flow back through the turbine generators at times when electricity demand is high. So here's another diagram. Flow of water to generate electricity, flow of water during pumping, and the power plant. All right, those are the questions that you're going to use at the end. All right, so today we had read this text, which is a technical text. And remember our LEQ, how do I explain the relationship of interactions between events or ideas within a scientific or technical text? So we talked about this relationship that was going on, that was in this text. And based on the title and text features, I feel that this is definitely a text that is a technical text because it has all different kinds of steps in it and is telling also different events that are going on and how they're all connected within the text. All right, so today, let's go back to Thursday. Oops, it's taking a little time today. All right, so Thursday, your bell work, and then today's reading, which is what we just did, and your Nearpod lesson, and then your independent work is the same thing that was the last page of the work. So it says use what you learn reading the technical text to respond to the following questions. The boxes below describe 4 events from hydropower. 2 events are causes and 1 event is an effect. 1 event results from that effect. The events are in no particular order. So these are just events here. You're going to complete the diagram by copying each event into the correct box. So you have to take these and put them here. Okay? Like we said, you can either take a picture, upload it, or post it or you can send me a text picture of it or anything like that.
We need door stoppers.
Okay.
We need door
And that's Miss
stoppers.
Montero. So I know that you guys miss us and we miss you too. So I'm looking forward to seeing your submissions and your what you're going to send to me. All right, so I'm going to hit stop for now until we do the next lesson. Thank you.